Okay, today we are adding and subtracting like fractions. This is chapter 3, lesson 5. Alright, so two like fractions are fractions with the same denominator, a common denominator. So here in words it says to add fractions with like denominators, you add the numerators and write the sum over the denominator. Here in the bottom example, you've got a common denominator of 8, so we know we can add just the numerators together and put it all over that, whatever that common denominator was. So here the 2 and the 3, which were my numerators, are added together, leaving me with 5/8, which cannot be reduced any further. In example A here on the next page, it says find each sum and write the answer in simplest form. Please don't forget to do that at the end. So here I have 7/10 plus 6/10, and I know that that is going to give me the same thing as saying, because those denominators are the same, I know that that really means 7 plus 6 all over 10. 7 plus 6 gives me 13. All over the same that same denominator there. And to write it in simplest form, I convert from that improper fraction to the mixed number. I know 10 goes into 13 one time with a remainder of 3, and I know that 3/10 cannot be reduced any further. Taking a look at example B here, I have 5/8 plus a negative 7/8. So if I say 5/8 plus a negative 7/8, some of you can look at this and recognize that a negative and a positive directly next to each other really means that that negative takes precedence over the positive. So I'm left with 5/8 minus 7/8. That's the same thing as saying 5 minus 7 all over 8, because that common denominator is what you write it over. 5 minus 7 gives us a negative 2 all over 8, and I know that this can be reduced. 2 goes into 2 once, and it goes into 8 4 different times, leaving with us with negative 1/4 as our answer. All right. Taking a look at the next slide here, it says find 2 3/8 plus 3 7/8. We're going to add mixed numbers this time. So our first step is to estimate, because 2 3/8 is closest to 2 and 3 7/8 is closest to 4. We're going to add those two together to get 6. So if our answer at the end is close to our estimate, chances are pretty good we have the right answer. The first thing that they do here is they take 2 and they add it to 3. They just separate those whole numbers because we had a common denominator. So really I get 5 plus 10 over 8, or 10/8. I know that 10/8 can be simplified to 1 2/8, which is the same thing as saying 1 1/4. So I add, remember this is the same thing as saying 1 1/4. So I'm adding 1 1/4 and 5 together. 5 plus 1 gives us 6, and 1/4 cannot be reduced any further. Because 6 1/4 is close to 6, we know that we have the right answer. All right, so to subtract like fractions with like denominators, all you do is subtract the numerators and then write that difference over the denominator. So here again in the example, you have 4/9 minus 3/9. Well, 4 minus 3 gives you 1, and 1/9 all over that common denominator is your answer, and it cannot be reduced any further. So taking a look at the first example here, you have 3/10 minus 9/10. Well, here they estimate first. They say, well, hey, 3/10 is actually closest to half, and 9/10 is actually closest to 1, and 1/2 minus 1 gives us a negative 1/2. So here in the first step, all they do is they say, hey, this is 3 minus 9, really all over 10, all over that common denominator, and 3 minus 9 gives us a negative 6. So negative 6 over 10 can be reduced because 2 goes evenly into both of those. 2 goes in there 3 times, and 2 goes into 10 5 times, and that's how they come up with negative 3/5. Since negative 3/5 is close to negative 1/2, you probably found the correct answer. It makes sense. Okay, taking a look at the next problem here, we're going to evaluate x minus y. So here's the original expression that you're evaluating, and all you're going to do is substitute in. X is going to equal 3 1/4, and y is going to equal 1 3/4. So the first thing you do is substitute, like I said. So you're going to replace x with those and y. Well, since we're taking away 3/4 from 1/4, 1/4 is less than 3/4, so we have to rename 3 1/4 before we can subtract, okay? So what we do is you take 3 1/4 minus 1 3/4, and you just have to rename. So we renamed 3 1/4 to 2 5/4. Now I can look at these and say, hey, I have a bigger number and I'm taking away a smaller number from that big number now. All they did was they made this a 2 because our whole parts are out of 4. I know that this 1 that I took away from the 3 is really a 4 out of 4, and I'm actually going to add it to whatever I have right here. So 1/4 plus 4/4 is actually where they're getting the 5/4 from. Now I can go ahead and say, hey, 2 minus 1 gives me 1, and 5 minus 3 gives me 2. So here, look over, 2 minus 1 gives me 1, and 5 minus 3 gives me 2/4. And I know that 1 and 2/4 is the same thing as saying 1 and 1/2. Okay, let's take a look on the next page. It says, LaShawn has 5 1/8 yards of ribbon to border scrapbook pages. If she uses 1 3/7 yarn on one page, how much ribbon is left? So the first thing we need to do is understand. This is going to be a subtraction problem. So it says, you know how much ribbon she has and how much ribbon she will be using. So our plan then is to subtract the amount of ribbon she uses from the total amount that was there, from that original amount. So to solve it, we know we're going to take 5 1/8, which is the total number of yards that she had to start with, and we're going to subtract 1 7/8 from that. Now, because some of you are looking at this, and I should have just shown you this to start, you're looking at this and saying, hey, I really have 5 minus 1, and I also have 1/8 minus 7/8. Well, I don't have enough right now. If I start with 1, I don't have enough to take 7 away from that. So I borrow from the guy sitting next to me. So we're going to cross this out right now, and what they did was they changed this to a 4 because our common denominator is 8, but one whole that I took away from here was 8 out of 8, and I have to add that to 1/8, which is how they get 9/8 right here. So I'm left with 4 9/8, and I still have to subtract the 1 7/8 from that. Well, 4 minus 1 really gives us 3, and 9 minus 7 gives us 2, all over that same common denominator, which is 8, and I know that that can be reduced. I know that 2 goes into 2 one time, and 2 goes into 2 goes into 8 4 times, which leaves me with 1/4. Now, because we're dealing with a word problem, you need to go back to the original problem, and it says how much ribbon is left. Well, the ribbon is written in yards, so 3 1/4 yards of ribbon is left. All right, on the last slide here, it says you can use the same rules for adding or subtracting like algebraic fractions as you did for adding or subtracting like numerical fractions. So let's take a look here in the first example, or in the last example, I should say. It says find 2 times a all over 10 plus 4 times a over 10. And then it says write it in simplest form. So the first thing that I'm going to do, 2a over 10 plus 4 times a over 10, is rewrite it. I know that because I have these common denominators here, I can just go ahead and add the numerators together. So I get 2a plus 4a all over 10. Now, one thing you have to understand, just to remind you from past years, is when you are adding different terms together, you can only add and subtract like terms. Well, what exactly does that mean? Just for some of you who are maybe a little bit confused or need a little refresher. So right now, if I had 2a and I had 2a squared, I would not be able to add these together. This is my final answer because my terms are not alike. I know right now that after the 2 I have an a, and after this 2 I have an a squared, which is really the same thing as saying a times a. So really I have 2 times a, and I have 2 times a. That is what that means. If I had 2bc plus 2bc, well, now I can add these. I look after my coefficient here at everything to the right of it, and if these match identically, then we can go ahead and add and subtract, or add or subtract those. So I really get 4bc. So now, coming back over to our original problem, because I have like terms, and I had that common denominator to start, I can go ahead and add those straight across. 2 A's plus 4 more A's in my pocket gives me 6 total A's, all over 10. And remember to write everything in simplest form. Now, because I'm dividing, right, this bar right here represents division, I can go ahead and just reduce. I can't divide because I don't know what A is right now, but I still can reduce. I know that 2 goes evenly into 6 3 times, and 2 goes evenly into 10 5 times. So I really get 3 times A all over 5. And that is your final answer in simplest form.